All right, finally getting into calculus. Everything we've done up to this point has been a blitz of pre-calc. We've moved at a blistering speed. We're going to slow down now that we're actually in calculus and spend more time on stuff. Because at this point forward, I'm going to assume I'm teaching you everything for the first time, even though y'all have seen limits before on some levels. So first look at limits. We're going to solve them with tables and by looking at the graph. And let's start by looking at the tables, or let's start by talking about just limits, the definition. If you see something like this, the limit as x approaches some number of f of x, what it's really asking is, what the heck are the y coordinates approaching as x approaches c? And the key part is from both sides. There is such a thing as a one-sided limit, where you're looking only from the right or from the left, which you would indicate with a small positive or a small negative right here. Otherwise, you're always going to be looking from both sides. So let's start with tables. And what I have here is I have a function, limit as x approaches 4 of x squared minus 16 over x minus 4. And I have gone ahead and filled out the table for you. We'll talk in class about how to generate the table on the calculator if you don't know already. In short, on the 89, you'll go to table set, and you want to set the independent variable to auto, or I'm sorry, to ask, and then you can punch in whatever values you want for x. So go to table setup, set the independent variable to ask, and then go to table, and then you can punch in whatever x coordinates you want. And I've punched these in, and we're approaching 4. And we need to look at both sides. Notice I left 4 out of the table. I didn't put it in because it's irrelevant. What's actually happening at 4 does not affect the limit. Limits really care about what's happening just to the left and just to the right. And that's what I've created here. I've created a table that the furthest away I get is 3.9, then I get a little bit closer to 4 at 3.99, then a little bit closer at 3.999, and the same thing on the right side. And the way I read this table is we look from the left, and I'm going to come this way, and I'm looking at my y values, so 7.9, 7.99, 7.999, and then from the right side, I'm looking at my y values, which are 8.1, 8.01, and 8.001. And what you have to decide is, do these two values look like they're going to the same thing? And these definitely do. These are actually approaching 8 from both sides. So I would say the limit of this function as x approaches 4 is 8, because that's what the left side and the right side were approaching. And that's by analyzing the table. So there's that one. Let's do this limit. It's 1 plus x to the 1 over x as x is approaching 0. And so what I've got here is I've left out 0, and I've gone just to the left and just to the right, and I've already generated the table. But if you look at these values coming from the left and coming from the right, do these values look like they're approaching about the same thing? And yeah, they are definitely converging. They're going to the same place. And this one is not as clear. On the one we just did, it looks pretty obvious that these things are going to meet at 8. This one is 2.719 and 2.717. I guess you could say these meet, if you're going to guess, 2.718. And if you said 717 or 719, I'm okay with that, but I'm going to go with 2.718. And if you're really astute, you'll remember our little history lesson the other day where we talked about the number E, and we said E is approximately, remember Andrew Jackson, 7th president, elected in 1828, served 2 terms, so we'll write 1828 again. He loved 45, 90, 45 right triangles. He's a big fan of right triangles. And then his favorite basketball player was Michael Jordan. And so we know that E is approximately 2.7, 1828, 1828, 45, 90, 45, 23, and that is actually what this limit is approaching. So the answer to this one is E, although if you wrote 2.718 or 2.7, I'm okay with that. And that's just by analyzing the table. We'll see. Let's look at a different table. Here we go. Limit as x approaches -1 of this. Notice I'm leaving -1 out of the table, and I'm looking just to the left and just to the right. As I look at the left side, my values 10, 100, 1,000. And I'll look at the left, my values are -10, -100, -1,000. These are going in complete opposite directions. The numbers on the left side are going up. The numbers on the right side are going down. These are not meeting. They're not going to the same place. Left and right sides must go to the same number. So this limit, we would say, does not exist. Maybe I should write it out the first time, but we'll use D and E. That is accepted by the Math League of America, D and E. So we would simply write D and E from now on, but know that that means does not exist. And it's usually at this point people start having flashbacks to the movie Mean Girls, and they start saying the limit does not exist. So here we go. Looking at that table, let's look at one more with the table. No, let's not. I thought I had one. I could have sworn I had another one. That's interesting. Oh well. So there's one where the limit does not exist. So there's a table, and you look at the values from left and right and hope that they meet at the same place. So if you're not looking at a table, if you're looking at a graph, personally I believe this is the easiest way to solve a limit, is to have an accurate graph. So looking at x is approaching 3 of this function, and I guess I'll start numbering these. We'll call this number 1. We'll call this one number 2. So the limit as x approaches 3, what I do is I will visualize, and for now I'm actually going to draw it in there. I'm going to visualize a dotted line at x equals 3. And what I want to do is approach that line, x equals 3. We're going to come from the left and from the right. And if the left and the right sides meet, then the limit exists. Now this limit, left side and right side, are both going to that point, and the y-coordinate of that point is 2.5. So this limit is 2.5. Number 2, I'm going to do the same thing. Limit as x approaches 2. And this is where people start to get a little bit confused. There is a hole at 2. My function is not defined. So if I were to say, what is f of 2? Well, f of 2 doesn't exist. There's a hole. So f of 2 does not exist. However, that does not affect the limit. What's actually happening at 2 has no bearing whatsoever on the limit. So I'm going to move my little vertical line over here. And again, if I'm approaching 2, I want to come from the left side. I'm going to come from the right side. And as I get really, really, really close to x equals 2, the left and the right sides do go to the same place. They're going to that hole, and the hole is at a y-coordinate of 4. So that's the answer to this limit. It does not matter that there's a hole in the graph. There is still a limit because left and right sides are going to the same place. So there's the answer to that one. Let's see, moving on. Number 3 here. Okay, limit as x approaches 0. So let me pull in my vertical line at x equals 0. And for this limit, again, I need to look at left and right sides. Left side, and out. Right side, and out. Are they going to the same place? Yes, they are. They are going towards the origin. There's a hole there, but the left and the right sides are both going to a y-coordinate of 0. But you may be asking, hey, that's not at all what I wanted to do. Oh, jeez. Okay, I want to move that. All right. But you may be asking, what about that point? Because there is a point right here. They have redefined the function at 0. That removable point does not affect the limit. What that does affect is if I asked you for f of 0. If I say f of 0, I want to know what's happening exactly when x is equal to 0. And at 0, I actually have a point at a y-coordinate of 1. So f of 0 is 1, but the limit is 0 because my left and right sides are going towards the origin. Same thing's happening on we'll call this one number 4, in red. How exciting is that? Limit as x approaches 1, I'm going to come from the left, and I'm going to come from the right. And left and right sides are going to the same place. They're going to the top of that little corner where there is a hole, but the hole doesn't matter. My limit is still, as I approach 1, my hole is at a y-coordinate of 1. So the limit is 1. Left and right sides both going towards 1. But if I asked you for h of 1, well, h of 1, now h has been redefined at 1. We removed the point and we stuck it up there at 2. So h of 1 is 2, but the limit is still 1 because that's where the left and right sides are approaching. I think I have 2 more. 2 more. Okay, here is the graph of the absolute value of x minus 5 over x minus 5. And I want the limit as x approaches 5. So as I'm approaching 5, here's 5 right here. I'm looking at the left side down here. I'm looking at the right side up here. And left and right sides do not meet. They're going to 2 totally different places. So this limit does not exist. In order for the limit to exist, left and right sides have to be approaching the same y-coordinate. And they are not. The top side, or the right side is going to 1. Left side is coming in at -1. So the limit does not exist. And then the last one here, This one I gave you one graph, and we have a buttload of questions. So starting at the top, f of -2. Now that's not a limit. I'm asking specifically what's happening at -2. So I'm going to find -2, and I'm going to look for a point, or I'm going to look for the graph, and that is actually a vertical asymptote. There is no defined point at -2, so f of -2 does not exist. I guess I'll write equals does not exist. Number B, the limit as I approach -2. Now, even though the function doesn't exist, does not mean the limit doesn't exist. The limit may still exist. So I've got to look at -2. Here's -2, and I'll look at the left side, and I'll look at the right side. Do they meet? Are they going to the same place? No, left and right sides disagree. They're going to completely opposite directions. So the limit also does not exist. In this case, the function and the limit don't exist. How about f of 0? F of 0. Now I'm looking for when x equals 0. So here's when x equals 0. I need to find my point. Find my point. There's an open circle that doesn't count. Here's the filled-in circle up here. F of 0 is 4. But the limit as you approach 0, now I've got to look at the left and right side. F of 0 is 4, but as I come from the left, I'm coming down here. It looks like 1/2. Coming from the right, I'm going up to 4. Those do not exist. So my limit does not exist. Sorry, those do not meet. What's wrong with what's happening here? Die. Die! Okay, D and E. There we are. So since left and right do not meet, the limit does not exist. Let's see, moving on. F of 2. I have a hole at 2. I don't see a redefined point anywhere. They didn't stick that point anywhere else. So F of 2 does not exist. There's a hole there. The limit as I approach 2 may be different. The function doesn't exist. Let's see, does the left side meet the right side at 2? And yeah, they actually do go to the same place. There's a hole, but they're still going towards that hole. And that hole looks like it's at a y-coordinate, I'm guessing, about 1/2. I'm going to guess 1/2. F of 4. There's my point at 4, and that looks like a y-coordinate of 2. But the limit as I approach 4, left side's going up, the right side's going up. And this one, there's actually 2 possible answers. They're both going up, but they never reach a specific y-coordinate. They're going up forever. So you could say the limit does not exist, and that would not be wrong, but we could be more specific. Since left and right sides are going up, they're going in the same direction, I would rather you say that this limit equals infinity, because both sides are going up. And if you say infinity, that tells me that they are going up. If you simply write does not exist, well, there's a whole bunch of ways that the limit could not exist. So infinity is a little bit more descriptive, although does not exist technically is not wrong. So there we go, kind of brief 13-minute intro to limits with graphs and tables, and I will see you in class either Wednesday or Thursday.